Unit 11, 11.1, random numbers. I went ahead, created my package. It's Unit 11. I import the random. I have a class called random numbers, and I have a main method. And the only method that I'm going to use is the main method to do everything. Two ways to create random numbers, and I'll see both of them in a second. First one is using the random class, which I imported up here, and then the second one is using the static call math.random. So here is a non-static way, and here is a static way. Okay, so we got a static way here and a non-static way. So we'll dig in. Let me just roll down here and show you, because I have everything here laid out, and we'll walk through all of this. At the very end, you'll have some examples down here that you could try. I would actually do them as well. So let's go ahead and look at random numbers. So a random number is literally generating a number randomly. Well, it's pseudo-random. It's not actually random, but good enough. The two ways, I'll do this way and then this way for every example until I get to the very end, and then you could choose a particular way. Now, the both produces the same random number that we want. We just never know how to do it. So let's go ahead with the random class first. First, you have to create a random number object, an instance of a class. And I call them gen and ran. This is the same thing I'm doing here. I'm just showing you that when I make these, I usually give them either gen or rand. Gen for generating random numbers, generator, and ran for random. So we have this two ways we can go ahead and generate random numbers. We can create a full range. Full range means all integers that can fit in 4 bytes if we're generating integers. And then the selected range is a range from A to B. Now, this is a mathematical construct here. It's called an interval. You either say half closed or half open. And the A is included and the B is excluded. Now, this is important because if I'm going from, let's say, generate numbers from 5 to 10, then 10 will not be generated. It would actually generate 5, 6, 7, 8, and 9 because the 10 is excluded. So the first number is included, the last one is excluded. If this was 0 to 1, then that means we're generating all numbers between 0 and 1. So we're starting at 0, 0 is included, but like 0 0.5, 0 0.999, those numbers are going to be included, not 1. Okay, that's very important. So we're going to go ahead down now and we're going to do some selected range generation. The full range, we're going to show that as well. So here we go. First thing I did is I created a full range. See how it looks? All I do is I take the name of the object and call the next int method right here. And this full range generates, as I said before, all values that can fit in 4 bytes because it's an integer. So I went ahead and print the full range. I'm not going to run this quite yet. The second one I generate is next int 10. 10. What's this 10? Well, 10 means 10 numbers. And computers always start at 0. Let me say that again. 10 integers starting from 0. That means we're going 0 to 9. You can write it like this, half open, half closed, or you could close it up and say it's going to go from 0 to 9, which is 10 numbers. So keep that in mind. This 10 doesn't mean generate a 10. It means generate 10 numbers. And those 10 numbers always start at 0. So I went ahead and I print that to generate some number from 0 to 9. Integers. Go down some more. I have a value of 3. We're generating doubles. Or well, doubles don't generate all that in 8 bytes. Now that's what happens. Doubles generate percentages. So they're between 0 and 1. Well, 0 included, 1 not included. So you could generate 0 all the way up to 0.9999. So you're going to generate a percentage. So if it generates 0.5, it's 50%. Generate 0.99, it's 99%. That's what the double does. So this is using the class. Okay, and I went ahead and printed it. The next one we can do it with is the math.random. Okay, so this is the class. So now you could choose any way you want to do it. If you want to do it this way, that's fine. If you want to do it the other way, that's fine too. Just choose one. Or I could go back and forth, that's fine too. So here we have the random with math. Math.random by itself generates doubles. So in essence, this math.random is the same as this. Okay, generates percentages. So it doesn't have a number in here. Okay, unlike next int and next double, we can't put a number inside here and here. So this math.random is double, this is double, no number go in. But when you're doing int, you can put a number inside. And this again generates percentages. Now, generating ranges is one of the things that we want to be able to do. So I have a bunch of them down here. We're going to just walk through them. If I want to go from 10 to 50, I can use either the generator from up here, gen or rand, or I could use math.random. So let me go ahead and just walk through what I've already done here. So value 5 is going to generate 10 to 50 and value 6 as well. So let's see what happens here. See this statement right here? 41 numbers starting at 0, that's 0 to 40. Let that one sink in. 41 integers starting at 0 means we're going to go from 0 to 40. If I add 10 to every single number, that's the way you want to think. We're going 10 to 50. Let that one sink in. 41 numbers. Doesn't generate the number 41. It generates 0, 1, 2, 3, 4, all the way up to the number 40. Any one of those randomly. And because we're adding 10, it will generate 10 to 50. Because if it generates 0, we're going to add 10 on. So we generated 10. If it generates the actual 40, which is the last number, then we add 10 on, we generate 50. And any number in between. How about doing it with math.random? Same idea, except it's a multiplication. Ooh, look at that. Casting. Why? Because math.random sends back doubles. Right? And if I take this off, we'll get an error. Because I can't turn 8 bytes into 4. Narrowing conversion. I can't do that. Instead, I want to make sure that it gets truncated. So take off the decimal, turn it into an integer for me, and then store it. So how does this work? Well, it's times 41. Not put 41 inside. Again, nothing goes in here. For the doubles, we don't put numbers in. Times 41. We could have done it the same way with the double up here as well. Okay, so that'll make it technically 3 ways to do this. But this times 41 cannot generate the number 41. Because math.random goes as high as 0.9999. 1 is out. So if I do this, it's going to generate 40.99999. But because we are truncating, because we are turning into an int, it doesn't round. It deletes, erases the decimal portion. So it's doing essentially the same as this, going from 0 to 40, adding 10 on for each number, and we get 10 to 50. Now here's some more down here. We are going to try doing those. Okay, so let's go ahead and do -30 to 20. So I'm going to say int value 7 equals to, I'm going to use gen.nextInt, and I'm going to put in some number and try to figure out how this works. So I think we're going to have to do a -30 here. Now, this is the easy part, because the number that goes on the end is literally the starting number every time, because it's included. Okay, see that? Starting number. Go up here, starting number. Always go inside, outside, I should say, on this. Okay, so if you're doing a weird range, see the number on the inside is the tough one. Okay, that's the one they have to figure out. But the one on the outside, it's whatever is here. So we could literally do all of these then. We're going to do the outside number first, okay? I'm going to change all those, and now scope, right? I'm in the main method scope, so it has a problem with these, right? It's saying, hey, you already did that. So of course we're going to go to 8, and then 9, and then 10. Okay, well, this one starts at 10, negative, and this one starts at -20, and this one starts at 1. And it's a positive one, not a negative one. So the number on the inside is the only one you have to actually figure out. So what we're trying to do here is we are thinking about generating these. Remember, these are closed intervals, so we have to generate the 20. We can already generate the negative 30 because whatever number I put in here, the smallest it can be is 0. And so since we're going to subtract 30, it could generate negative 30. But how do I get the 20? Well, if I put in a 20 here, will that work? Well, no, because this is going to generate 0 to 19. And then I'm going to subtract 30 from each one of those. So I'm subtracting 30 from 19. I'm not going to get to 20. So we got to go a little higher. Let's see. What about if I go to 50? Would that work? Well, this generates 0 to 49. And if I subtract 30, not quite there. So let me try 51. Well, this generates 0 to 50. So let's see how it works. If it generates a 0, we'll get a negative 30. We only need to figure out the first number and last number. Once we get those right, everything in between will be generated, okay? So we just need to figure out the negative 30 and the 20. Negative 30 is easy. Just put it right here. This guy now, we have to look at it and say 0 to 50. So if I subtract 30 from the 0, I got the negative 30. And if I subtract 30 from the 50, I got 20. Bingo, we found it. So now we got to figure out the bounds for this guy. Negative 10 is done. It's right here. So how do I get to 10? Well, let's try 21. This generates 0 to 20. When it generates a 0, subtract 10. We got this one. When it generates a 20, we subtract 10. We got this one. Getting the idea? Getting the idea? What's the bounds for this one? Think about what the bound is for this one. We want to go from negative 20 to negative 5. It's a little tricky one there. Let's see. Could I try 11? Let's see if that works. So 11 goes 0 to 10, right? So if I do it 0, I subtract 20, I get negative 20. But when it gets up to 10, if I subtract 20, I'll get negative 10. Ooh, a little bit off. So what number needs to go here? Well, let's try a 6. What would that do? Well, that goes from 0 to 5. If it generates a 0, I subtract 20, I get negative 20. If it generates a 5 and I subtract 20, I'll get negative 15. Ugh. I want this negative 5. So what should this be? Should it be 16? Let's try again. 0 to 15. Keep that in mind. When it generates a 0, I'll get the negative 20. That's fine. But when it generates a 15 and I subtract 20, I'll get a negative 5. We got it. Now it's time for this 100. This is the tough one. Always the last one is the tough one. So how about if we're going from, let's try 100. Let's see if that works. Well, if I generate a 0, I'm adding on a 1, so it'll be a 1. Okay, remember, this generates the numbers from 0 up to 1 less. All right, that gets me 100 numbers. So you're going from 0 to 99. The last number this can generate is 99, the highest, I should say. And when I add 1 on, I get 100. But let's go ahead and print these. Okay, so let's print these, and then we're going to run them and see how they behave. And I'm going to update all of these. So for example, this one is 7. So let's put a 7 there and put a 7 here. And this one is 8. Let's go ahead and fix all of these. And the reason for doing this is when we run this now, we're going to be able to see what the ranges are and if it's behaving the way it's supposed to. So, and this is 10. Right, I got to write the ranges as well. So this one is negative 30 to 20. So we're going to put that in here. And then negative 10 to 10. And if we see an error, we could always go back and change our code, but I'm pretty sure that we are all right here. And this one is that. And I'm putting down the range so that when we look at the numbers that are being generated, we want to make sure it's in the right range. All right, so now we have everything. We're all set. This is one of the skills you have to be able to master. It's not a difficult one, but you have to think before you write your code when you're generating selected range. I'm going to run it now. Let's see. Full range. See, some long number, and can't even call that number. It's too many digits. But once it fits in 4 bytes, you can generate it. All right, this is 0 to 10. So anything here needs to be in that range. Here are the doubles. Remember those? The percentages. Like this is about 11%, 80%. We're doing 10 to 50. It generates a 35. And it generates a 44 from 10 to 50. We did this two ways. And then we did these using just the random number generator object to do these, right? Non-static calls, remember? Non-static calls, as opposed to the math.random, which was a static call. I prefer using this, as you can tell, because the math.random is just more typing, right? So that's why I go with the next int. So now negative 30 to 20, 2 is definitely in that. 5 is definitely in that, negative 13 is definitely in that, and 26. How do I know this thing keeps working? Well, run it again. See? All you got to do is just check to make sure the numbers are within the range. Hey, we got a 50, right? That's the last number that is shouldn't say last, the highest number that this can generate. Wow, that's some very high scores here, 95% and 96%. Long number again, full range. 5 is within 0 and 10. And everything looks good. Let's run again. See, we're just getting the right range, everything. These are random generator. Just generating numbers randomly. Every time I click on it, get a different number. Can't tell you what number is going to come there because it's random. However, as long as it's within the range, we've done them right. So that's it. Random number generation. 11.1. That brings us to the end of 11.1.